Alrighty.
So it's 1, 6. Oh, so it's going to be 14C3 and then 8C3.
So are there any homework or lab questions you guys have? Any homework or lab questions? No? Okay, good. You guys sort of have realized that's really important who you work with, right? Or who you're around, because there's only one of me and there's lots of you, so working together is the best way of learning. You're going to learn more from each other than you're going to learn from me. For a couple of reasons. One is you guys kind of are more, you know where your pitfalls are, where you're going to get confused more than I am, right? Because you'll have just learned it yourself. So you learn better from each other in general. Also, for some reason, when I say it, I'll say it 5 times during class, and someone will explain to somebody else and say, "Oh, now I get it." And I'm like, "I just said that same thing." But so somehow you listen to each other better as well. So it's make sure that you're working, that you're around other people who can answer your questions, and if not, then maybe you and your partner should move somewhere else where you can ask some questions, right? So you're not isolated in some corner of the universe. And so after the exam, feel free to move around for a little while and find a different spot you want to sit. That's totally fine. Everything good? Okay. All right. And what else was I going to say? Oh yeah, and explaining, right? So the great thing is that you learn more by explaining than if you didn't explain, because it's harder to explain something than it is just to know it. So that process of having to explain it to somebody else helps you learn it better. So really, this whole group work is better. It helps everybody so much more. It's just a really good thing. So, do that. You guys have realized you can pop down these computers and work across the aisles as well, which is really good. So yeah. What else? We did that. You guys know that Connect Math 4.4 is due today. I will say this one time. Do not use the help buttons in 4.4. Where they say, "Show me an example." They were more confusing than they are helpful, I think.
The one due today?
Yeah. So if you just do it my way, it's going to be easier than doing it that way, because their way involves memorizing a formula. And I don't think you should memorize the formula. I'm against you memorizing formulas. I'm more about you guys learning how to use logic and figure out how things make sense. Because part of math, the reason why we make you take math is because it's reasoning, right? And logic and reasoning, and how to reason out problems. Not about, and which is more useful in life. Learning how to reason or learning how to memorize formulas. Right? So that's going to be something, reasoning is going to be something that helps you with your job in the future, with just general life things in the future, keeping people from ripping you off in the future, all sorts of stuff like that, right? So it's important to have that. Okay. Next Thursday, I might move that a little bit. I want Project Part 2 be done. It's posted up on the web. It's basically picking your four things and copying them over. I'm probably going to have to put that back because I didn't show the other classes, so I'll probably have to. If you want to start on that, you can. I think people, after tonight, don't do it before tonight, because I need to go in tonight to make sure everybody's data is right before people start messing with it. And I also need to lock it so that people can't go in there and delete things accidentally, right? Because that's going to happen. So don't copy anything tonight. Let me go in there tonight and lock it down and fix it all and everything else before people start copying in there. All right. And exam 1 is on Tuesday. I will give a review on Monday. My office hours are going to be instead 2 review sessions in 600. Over there, I'll do one from 3 to 4 and another one from 7 to 8. And if you guys are in there from 7 to 8 and you have some more questions, I might let it roll till 8:30 if you guys still have questions. But try to get there by who thinks they would not get there at 7. They might be running a little bit late after that. Okay, so we should work out something. Maybe I'll try to do it in the outer room so that we can just let you in. Or I'll leave the door unlocked and we'll be around the inside or around the corner. One or the other will happen. So that you guys can not be locked out. Okay. Exam 1. This is the same stuff we talked about before. Half page, one-sided of notes, one-sided, handwritten by you. Also, even though you can use a calculator, you still have to write down the formulas for all these things we're doing right now, this last section we've learned. So you cannot just put in the calculator, you can't just put down 10p3 and just find it in your calculator. I want you to write down this times this equals blank. Because this is not a test about do you know how to put something into your calculator. It's do you understand where the theory behind it. Yeah.
Yeah, what if you write down the numbers you put into your calculator, but you don't know the formulas, P3, C, whatever?
I don't care about that.
Okay.
So you don't have to put down 10p3. If you just write down 10 times 9 times 8 equals, I'm happy with that. You don't have to know that it's a P or it's a C. You just have to know how to find it.
Can we abbreviate factorial, or do we need to write that out as well?
I would prefer it to be written out.
Okay.
And you're not going to have anything like 200 factorial, so
Well,
it won't be crazy like that. Okay. Okay. I mean, it's going to be like 9, right, or 10. You can write down 10 times 9 times 8 times 7 times 6. Also, make sure you bring your binder if you want extra credit. So make sure you bring the binder. Don't leave the binder at home. No binder, no extra credit. Smart shops, if you've gone to some smart shops, there's those little tags they give you at the end, attendance slips. So bring those in. They're each worth a half-point extra credit, up to 2 smart shops. So I'll take them from you, I'll tear them in half and give you your point on the exam. If you have tutoring sessions, 4 of those in the tutorial center or the math lab or over here, just bring in the paperwork. There's some sort of printout they can do for that. If it's over there, just let me know, I can look it up. And then support course, if you're in a support course, I think a few of you guys are, just write down support course, and I'll check the roles and make sure you've been attending that, and then I'll give you points for that. Okay. Jim Hannum, just a reminder that he's tutoring over there. So someone had said, it's not going to help you guys. You guys are in there from 6 to 7:15. Okay. So, great. So hopefully you guys can help each other. And the instructor that's in there has taught statistics before, so he should know how to help you if you have questions. Pretty much. Like I do some things that are maybe a little bit different than other people, so maybe not 100%, but he should be able to help you with most of it at least. Okay. All right. Counting rules. Fundamental principle of counting. Why am I reading? Adam, read.
The fundamental principle of accounting. The total number of possible outcomes of a series of decisions is found by multiplying the number of choices for each decision. Example.
Great. Keep going.
2 pants, 3 shirts, 5 shoes, 4 socks. How many possible word combinations?
Good.
Question.
Thank you. So, what I think you should do, how many decisions are you making? 4. So first thing I would recommend you do is just write down 4 lines.
Well, you got that.
And then, how many options for the first choice?
2.
Next choice?
3.
Next choice?
4.
Last choice? Makes sense? So that's the easiest way of doing it. Write down a line for each decision you're making, so then you just kind of fill those in, and it takes some of the thinking out of you so you can focus on what you need to focus on without, it decreases the amount of working memory you have to use to maintain that part of the problem. Does that make any sense? So it allows you more working memory to work on the rest of it. Okay. Quiz number 3. Call it as a radio station. Must have 4 letters. How many decisions am I making? 4. You're picking 4 letters. Everybody on board? So draw out 4 lines. All right. So the first letter has to be a K or a W. How many options? How many choices do you have for that? 2. Then there's 26 letters in the alphabet. If you are unsure about any of those things on the test, feel free to ask me that if that comes up. I should tell you there's 26 letters in the alphabet, but if I neglect to for some reason, you can always ask me. That's totally acceptable. So here, you cannot repeat it. So if I picked a K, I can't pick a K again. But I could pick a W. If I picked a W first, I can't pick a W again, but I could pick a K. So after I pick my first letter, how many options are there for my second letter? 25. 25, right, because there's 26 in the alphabet. I've picked one already, there's 25 left. After I pick that one, how many are left?
24.
After I pick that one, how many are left?
23.
Great, and what do you guys get? 27,600? Okay, sounds good. Counting rules, factorial. It's the product of all numbers from that number down to 1. So like 4 factorial would be 4 times 3 times 2 times 1. It's the number of ways of arranging that many items. So 3 factorial, number of ways of arranging 3 items. Okay, good. So, quiz number 2. How many trophies can be lined up on the shelf? The question comes up of, how do I know if order matters? This is the easiest way that one of my students said, is when you're picking stuff, if you pick things and you just stick them into a bin, and they're all kind of rolling around and they're like chaos, order doesn't matter. But when you pick stuff, you're putting them in specific places. Like, you're going to be named Spot. You're going to be named Fido. You're going to be named John. Or you're going to be washing dishes. You're going to be, I don't know, calling off names. You're going to be sweeping the floors. If you're assigning things to people to things or positions or places, or you're first, you're second, you're third, then order matters. Right? If they're all just kind of getting pulled in and they're all kind of getting mixed around, order doesn't matter. That's chaos. That's the combinations part. That's the one where you have to divide out the duplicates. That's the unusual one, chaos. The normal, ordinary one is when order matters. You're putting them in particular places. This one is you're putting things in a particular place. How many items am I choosing? 9, all 9 of them. I'm going to pick all 9 of them at some point, right? So 9. And how many options for the first spot? Next.
8,
Next.
7, 6, 5, 4, 3, 2, 1.
Blast off. Okay, good. All good? What's that answer, by the way?
362,800.
Okay, good deal. So again, permutation is when you cannot reuse items and order matters. So, for example, remember when I was picking my PIN number from my phone, and I could do 0000 from my PIN? Apparently I'm not supposed to, but you can, right? That you can reuse items. Also, we have like the shirts and the pants and the socks. Those are like separate categories. Those aren't even from the same group. Permutations and combinations are when you have a giant pool that you're picking from, and once you pick it, like you pick a horse to win. You can't pick the same horse from the next place, and you can't pick the next horse. So when you choose a horse and he comes in a certain spot, you got to pick a different horse. Or students, you pick a student, you got to pick a different student. That's when you're talking about permutations and combinations, when you cannot reuse items. So here, permutation is when you cannot reuse an item and order matters. When order matters, you're putting them in a specific place. Permutation, this is a permutation. I think this is the best sort of formula for a permutation. I think it's better than the books. It's clearer, it makes more sense. Right? How many spots do you have? I'm picking 3 things, I have 3 spots. Right, so here, I only care about the top 3 finishes, so I'm picking 3 horses, drawing 3 spots. How many, and then they're going to start with N. I have 8 horses, 8, 7, 6. Done. Everybody on board? Super straightforward. Quiz number 2. Decagon. So you're arranging. Anytime you have arranging, that means you cannot reuse items. You have one of each. That's basically, anytime, so arranging, you're not really picking them, you're just taking them and you're arranging them, those same 7, using each one time. So this is the same as 7 factorial, right? 7 times 6 times 5 times 4 times 3 times 2 times 1. And you guys got what? 5,040? Now, if I'm taking a 4-letter permutation from the letters, so you cannot reuse letters, how many things am I picking? 4. Draw 4 lines. How many options for the first spot? 7. Next spot? Next spot? Next spot? Great. How many altogether? 840. Sounds good. What if you could reuse letters? So how many do you want to pick? 4. So some of you, that's why I said 7, that's fine as well. I was kind of vague about that one. And so that's also acceptable. How many options for the first letter? Next letter? Next? Next? Right, because you can reuse them. So what was that answer? Good. Do you guys want 30 seconds to check in with your neighbors on this? Yes? Yeah. Okay, go ahead, take 30 seconds. All right, let's take a look at the next one. So that's permutations. Then we have this thing called combinations. When order doesn't matter. Remember my other student called it chaos. So it's when all these guys here, Alex, Ross, Rigo, is the same as Alex, Rigo, Ross. It's the same as Rigo, Ross, Alex. They're all sort of, they can all get mixed up and moved around. Right? So all those just count as one. They're all the same thing. Because we only care about the group and not what order the group is in. So these all just count as 1. So instead of 24, there's only 4. You have to divide out the duplicates. The duplicates are how many are in each group. In other words, you have to divide by r factorial. Yeah?
On the exam, do you want us to write like the middle part of that, or do you just want us to write like the last part? Just like a small
I only want this.
Okay. Cool.
I don't need that. Yeah. Okay. So so this is sort of what I think the best thing is, the best kind of formula for combinations. First, you have just your permutation, and then you add the extra step of dividing by r factorial. Right, so the first part is just the same as the last part. That's just the permutation part, but you have the extra step of dividing by r factorial. So here is an example. So this guy is selecting 4 different photographs of an advertising flyer. This one, it's kind of unclear whether order matters or not. So this would be a great time to say, Ms. Young, does order matter? And I would say, oh, I'm sorry. Order does not matter. Now, on the exam, if I feel like you should be able to figure it out, then I might ask you a question. I won't tell you, and instead I might ask you a question to help you maybe try to figure it out. That's a hint that you should be able to figure it out on your own, somewhat, right? So, order doesn't matter. So it's sort of chaotic, right? We have the extra step of dividing out the duplicates. How many things am I picking? 4. I'm picking 4 photographs out of 9. So 4 spots here. This is an example. How many options for the first spot? 9. Next spot? 8. Next spot? 7. Last spot? 6. All right, so here, if you put in the number of lines you want, you just know when to stop. You just keep going down until you get to the end, until you get to the last one. And then, because it's a combination, chaos, right? This is 9, choose 4, in case anybody cared. Then, we just divide by 4 times 3 times 2 times 1. They should all match up. 1 for each one of these. Right? I could have just started from there and just gone 1, 2, 3, 4. Or theoretically, you could go 1, 2, 3, 4 if you wanted to. I guess I'd be okay with that. Okay. Does anybody need an extra, do you guys need an extra minute or two? So videotapes, you go to the store and they say, okay, you can pick from these 8 videotapes, and you pick 8 of them, or these 10 videotapes, you pick 8 of them. Does order matter? No, you're taking them home. Does anybody need a minute or two to finish these 2 questions? No? Ready to go? Okay. So order does not matter. So it's going to be, yeah, it's going to be 10, choose 8. So I'm going to have, how many things am I picking? 8. I'm picking 8 items.
Out of 10.
And I'm going to start with 10.
9, 7, 6, 5, 4, 3.
And then, because it's chaos, right, because it's a combination, order doesn't matter, I need to do that extra step of dividing out the duplicates.
8.
So I have 8 of them, 8, 7, 6, 5, 4, 3, 2, 1. Then the beautiful thing is that a bunch of these kind of cancel out. I'm left with 90 over 2, which is 45.
Pretty smart.
No, I just, that one works out really easily.
Yeah, 100.
Divide. You got 45
They just cancel like the same number, like we combine them.
All right. So then next, we have quiz number 5. How many ways can you award first, second, and third from a group of 7 contestants? Does order matter?
Yes.
Yeah. First place is way better than third place. So how many things am I picking? 3. So it's going to be 7, pick 3. 3 spots. 1, 2, 3.
7, 6, 5.
Yep. Start with a 7. 7 times 6 times 5. 210. Done.
That's it?
All good? That's it.
So I'm a lab for lab number 8 on the notes.
Uh-huh.
I don't know why. Maybe I'll just say it feels bad, right?
Yeah.
That's not right.
Professor,
Yes.
for combination or permutation, which one does it not matter and matter for repetitions?
Oh, good question. So the question was, for combination or permutation, which one is it all about, like, if you can repeat or not repeat? And the thing is, both of them are where you cannot repeat or reuse letters. Both of them. Great question. So combinations and permutations are only when you cannot reuse items. You cannot repeat. You can't use them over and over again.
So
I'm sorry?
if it was given the same, what did everyone have the same?
So like, I have a whole bunch of letters. Once I pick one, I can't use it again.
Okay.
Or I have a whole bunch of numbers. Once I pick one, I can't use it again. I have a whole bunch of students. Once I choose one, I can't choose the same one again.
But if you could use all of them, then you just times the same number. That's right. So if you had all of the letters, so say 26.
Yeah, then I'd pick 26. If I can't reuse them,
Yeah.
26, then 25, then 24, then
Or if you
23.
can.
If you cannot reuse them.
Okay, got
If
it.
you can reuse them, then it's not a permutation or a combination.
And then you just what would
It's
you
just
do?
use just regular fundamental counting principle.
Okay.
Yeah. Right. So if you can reuse them, it's just a fundamental counting principle. And actually, in general, you can always use the fundamental counting principle. It's always quite valid. That's when, yeah, the fundamental counting principle. The only time you can't is that word case of combinations.
What is that first word you're saying in the last sentence? What's that the founding principle?
Fundamental counting principle. Yeah. All right. Quiz. Oh. Okay. Quiz number 6. I roll a die. Who finished 6 and 7? Who's done with 6 and 7? Who's not done with 6 and 7? Who's done with, who's not done with 6? Okay. So we'll take a look at number 6. We'll do it together, kind of. I have a die. Here it is. I roll it. What's the probability I roll a 4? Yeah, there's 1 4 out of 6 spots. So there's a 1/6 chance of rolling a 4. What's the probability of not rolling a 4? 5 out of 6. Good. So probably I don't roll a 4 is 5 out of 6. Okay. Now here's the thing. I'm going to roll this dice. The first time I roll it, the probability of not rolling a 4, 5 out of 6. What about the second time I roll it? Will it change? You guys sure? Yeah, because it's the same dice. Right? Every time I roll this dice, it's still 5 out of 4 chance I don't get a 4. 5 out of 6 chance I don't get a 4. Does that make sense? So that probability doesn't change with this. And I'm not taking numbers off the dice. So the first roll, 5, 6 chance I don't. I want to know the probability that I roll it 5 times and I get no, 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 and no. No every single time. So, and maybe we'll draw a quick, I'll do a quick little thing here. So either I draw a 4 or not. You said 5, 6 chance of not, 1, 6 chance of drawing a 4, yeah?
Yeah.
Then the second draw can be either a 4 or not. 5, 6 chance of not rolling a 4 there. And then I draw it again. 4 or not. 5, 6 chance. Exactly. It doesn't change. Each time I roll it, probability is still the same. 4 or not. Last time I roll it, 4 or not. I want to know the probability. I end up right here. Right? So, not and not and not and not and not. Every single time. So this, 5/6 of the people pass this test. 5/6 of those people, 5/6 of 5/6, pass the second test. 5/6 of them, so 5/6 of 5/6 of 5/6 pass that test. 5/6 of those folks pass this test, and out of those, 5/6 of them pass the test. So 5/6 of 5/6 of 5/6 of 5/6 of 5/6 pass all the tests.
5/6 to the 5th power.
5/6 to the 5th power. So this here would be, like Adam was saying, 5/6 to the 5th power. Because we need the first one to not be a 4, and the second one to not be a 4, and the third one to not be a 4, and the fourth one to not be a 4, and the fifth one to not be a 4. And we multiply. Everyone say and we multiply.
And we multiply.
Try it again. Ready? 1, 2, 3.
And we multiply.
You need to say that. Say it to yourselves 10 times when you leave this room. Say it 10 times before you go to bed. The next 5 days from now, the exam, say it to yourself 10 times at some point. So you really get that lodged in your memory. You need to totally know that going to the exam. So it's just a total. All right. So we're going to multiply.
So you get
And you'll end up getting what?
0.402.
0.402. Yeah. If you round correctly, you get 0.402.
Yeah.
If you had done, if you got 0.4010 something, because you rounded this to 0.833 and then did it to the 5th power, did anybody do that?
I got like 0.40.
Okay. So if you had done this, if you had done 0.833 to the 5th and gotten 0.401, that's okay if you give me this also. So I know that you had that rounded in the between. Because really it's supposed to be 0.8333333, right? But because you round to the 3rd decimal place and then raise it to the 5th power, you're going to get a slightly different answer. If you write that and then write that, you're fine. If you don't write that and just write this and then write 0.401, then I'll take off half a point for rounding. Does that make sense to everybody?
Yeah.
So if you show me what you did, and then I know that, oh, they rounded there, so then that's why they got 0.401. Then we're all good. Or just give yourself like 5 decimal places and then do it, and then it's probably not an issue. Right? Okay. Now, probably at least 1 is a 4. Whenever you see at least 1, instead write 1 minus probability, and then whatever this says, the at least 1, instead write none, then whatever this is, write it down, whatever this is, write it down exactly the same way. None, 4. Bad English, who cares? So none 4 means no 4s. Is everybody okay with that part? So 1 minus probably have no 4s? Oh, I already know that. How simple is that? 1 minus 0.402, 0.598. Good? Good.
You're a little forgiving about the decimal point. So earlier I did it all by calculator.
Uh-huh.
I kind of wrote rounding, so I got 5.99, something like that. So like, it's going to be like.
Okay, if you got 0.401 here and you got 0.599 there, that'd be fine. These should match each other.
Okay.
So if you got 402 here, you should get this here. If you got 401 there, you should get 0.599 there. But these two should add up to 1. If they don't, then that's trouble. Okay.
Thank you.
Problem 7 is very similar, except here's the deal. I have 22 kids on a bus. I'm picking 3. Am I going to pick the same kid over? If I'm picking 3 kids, am I going to pick the same kid over and over again? No. You're going to pick 3 different kids. So that changes. Once I pick a kid, all of a sudden there's no longer 22 kids on the bus, right? The probabilities change. So you should think about that. Let's take a 10-minute break. So we'll come back at 42 after. And if you haven't gotten this problem done, work on getting that problem done during that time a little bit as well.